Well, hey class, this is for the Algebra 1, section 9.1, dealing with radicals, and this is going to be part 2 of the video, so we're going to be dealing with multiplying and dividing radicals and radical expressions. Radicals are just square roots again, just to recall. The radical is the actual symbol, whereas the radicand is what goes underneath or inside of the radical. Now this would go along with the IXL skills EE4 and EE3 for the multiplying and dividing radicals. So with our note packet here, continuing on, multiplication. So when we multiply radicals or radical expressions, we multiply the radicands and simplify if possible. So for example, here on number 1, square root of 3 times the square root of 15, or radical 3 times radical 15, however you want to word it. We multiply the 3 and the 15 together since they're both underneath radicals. They are both radicands. So 3 times 15 is 45, and so we have the square root of 45. Now, we're not quite done because it says simplify if possible. So what we have to do now is say, okay, just like we did before in the previous part of 9.1, is we have to go through and see, are there any perfect squares that are factors of 45? And I would say, well, square root of 9, or 9, goes into 45. And how many times? Oh, 5 times. So square root of 9 times the square root of 5 is equal to the square root of 45. Now I chose the square root of 9 because it's a perfect square, because if we actually take the square root of that number, we get normal 3. So now we have 3 times the square root of 5. And that would be our answer, because we cannot simplify the square root of 5 anymore. Continuing to the next problem, square root of 5 times the square root of 10, same idea. They're both radicands, 5 and 10, so we can multiply them together and get the square root of 50. Well, now we can go through and simplify and say, well, square root of 50, square root of 25 is a factor, and it multiplies with the square root of 2. Square root of 25 is normal 5, so we have 5 times the square root of 2. Last but not least, 2 times the square root of 2 times 3 times the square root of 2. What we do here is we multiply the numbers outside the radicals together. So we multiply this 2 and this 3 together to get 6 on the outside. And then we multiply the numbers inside the radical together as well to get our new radicand. So 2 times 15 would be the square root of 30. And we say, okay, well, can we simplify? Are there any perfect squares that go into 30 that are factors of 30? And if we check every perfect square that's lower than 30, 25, 16, 9, and 4, none of them do. So this actually just ends up being our answer, was 6 square root of 30. Continuing on. We're going to move toward division, okay? So division, we divide the radicands and then simplify if possible as well. So it's handled very similarly to multiplication, especially how we saw that last multiplication problem is how we're going to solve this number 4, where we have these numbers outside the radical of 10 and 5, and we're going to divide those normally. So 10 divided by 5, well, that can simplify to 2 over 1. We don't have to write the 1 if we don't want it underneath. And then, okay, then just like we did with the multiplication where we multiplied the radicands together, we're going to divide the radicands and simplify those as best as possible. Well, 50 and 5 goes into both. So we end up having square root of 10, because 50 divided by 5 is 10, over the square root of 1. So we have 1 times the square root of 1 at the bottom. But at the end of the day, what is the square root of 1? Well, it's 1. So that makes our bottom 1 times 1, which is just 1. So we don't even need the bottom there. So truthfully, our answer is actually just 2 times the square root of 10. And we'd want to check to see if we can simplify, but we can't simplify anymore. Moving on to the next problem here. 3 square root of 24, over 2 times the square root of 3. Well, 3 and 2 can't simplify, so we're just going to leave that 3 over 2. Square root of 24, haha, and square root of 3. Well, 3 goes into both of those. And it goes into 24 8 times and 3 once. So we end up having 3 times the square root of 8 over 2. We take one more look at that and say, wait, square root of 8, I think I recognize that to be the square root of 4 times the square root of 2. That helps us because the square root of 4, if I go down here, is normal 2. So we have 3 times normal 2 times the square root of 2 over 2. Now, if you catch it here like we did before when we factored, we can actually simplify this 2 and this 2. Since there's multiplication, that wouldn't work if there's addition, but it works because there's multiplication there. If you don't catch that, well, multiply the 3 and 2 together, 6 square root of 2 over 2, and then say, oh, wait a second, 2 goes into both those numbers. So we end up getting 3 times the square root of 2 over 1, aka 3 times the square root of 2. So it started as 3 square root of 24 over 2 times the square root of 3, ended up only becoming 3 times the square root of 2. So simplified down quite a bit there. Let's try rationalizing these denominators, okay? So let's first talk about what that means. So we don't want to have a radical in the denominator of a fraction. And if you recall, denominator is the bottom of the fraction, the bottom part. So in order to make it a whole number on the bottom, so we don't have a radical anymore, we multiply the square root, whatever's down there, times itself. So, for example number 1, when you have 1 over square root of 2, we say we don't like this radical down here. So, let's multiply the bottom by the square root of 2. Because what's going to happen in effect is we're going to have square root of 2 times square root of 2, which is the square root of 4. And hey, that's normal too. And but the thing is if we also have to adjust the top, because if we just multiply the bottom, then what happens is we end up changing the value of the actual number. So what we have to do is we have to multiply the original by square root of 2 over the square root of 2. Because the square root of 2 over the square root of 2 is the same thing as 1. Because anything divided by itself is 1. So realistically, we're not changing the value of 1 over the square root of 2 because we're only multiplying it by 1. And I would put that in air quotes there, we're multiplying it by 1. So we're not changing the value, we're just making it look different. Okay? So multiply the square root of 2 over square root of 2. So now on the top of this fraction, 1 times the square root of 2 is normal square root of 2. And so on the top, you end up having square root of 2. On the bottom, it's divided by normal 2. And we might look at that at first and be like, well, that seems actually a little more complicated than what we started with. And even though it might look at that at first glance, we still end up finding it handier in later math to have this rationalized. And so we leave it this way as square root of 2 over 2. And sometimes we end up realizing things that we can simplify out that we couldn't have simplified out before. Continuing on, number 2, 2 over the square root of 3. We don't want that square root of 3 down there, so we have to multiply the bottom by the square root of 3. But just like on the last problem, we can't only multiply the bottom. We have to multiply the top by the same thing. So that way we're really only multiplying by 1. Because square root of 3 times square root of 3 divided by square root of 3 would just be 1. If we multiply straight across, 2 times the square root of 3 is just 2 times the square root of 3. We can't make it 6 because 2 is not under a radical, whereas 3 is. On the bottom, square root of 3 times the square root of 3 is the square root of 9. So we end up getting 2 times the square root of 3 on the top over normal 3. And that's our answer because there's nothing else that we can simplify. Now, you might be noticing a small pattern here. And if you are, great. And if you haven't yet, just hang on 1 second because we're going to talk about it right after number 3 is done. So 12 over the square root of 5, we have to multiply by the bottom by square root of 5 to make that a whole number down there. And so we're going to choose to multiply the top by the same thing, so we keep it as 1. Top becomes 12 square root of 5. Bottom just becomes square root of 25, because 5 times 5 is 25. I'm going to move my work down here. So 12 square root of 5 over normal 5. And that's our answer. Now what you might be noticing now, guys, and hopefully you are, and if you haven't, well, maybe this will point it out, is that the bottom number each time, 2, 3, and 5, what we end up with down there after we, the first whole number we get down there, is the same number as what the radicand was originally. Same number as what the radicand was originally. Now what ends up happening, guys, to make that happen, is that anytime you multiply any two of the same square root, you end up getting that number normally. So like here, square root of 3 times square root of 3, we're going to get normal 3. Square root of 5 times square root of 5, we're going to get normal 5. So what you can actually do, like I'm drawing these arrows here, is you can cut out that middle step if you want, of calling it the square root of something else. So let's actually try that in this next problem here. 3 times the square root of 5 over 2 times the square root of 2. Now you might be wondering, Mr. Kossel, what are we going to multiply this by? Are we going to multiply the top and bottom by 2 square root of 2? And I'd say, well, you could, but you certainly don't have to. And so I would advise against it, just because it ends up creating some more than we actually need. What we're really concerned about is just the radical down here. So let's just multiply it only by the square root of 2. Once again, we have to do it to the top and bottom, so we're not changing the value. So on the top, 3 times the square root of 5 times the square root of 2, well, we can multiply the square root of 5 times the square root of 2 and get the square root of 10. On the bottom, 2 times the square root of 2 times the square root of 2. As we just talked about, square root of 2 times square root of 2 will give us normal 2. So we really have 2 times normal 2. And if you wanted to, you can write that as 4. Now, if you need to see that as extra steps there, then that'd be 2 times 2, and that'd be 3 square root of 10 over 4. And don't forget that hidden step that we just skipped over because we said, hey, we noticed this pattern. Because off to the side of the math that happened there, on the bottom was 2 square root of 2 times the square root of 2 was 2 times the square root of 4. And hey, the square root of 4 was 2. So that's the math that secretly happened at the bottom there. But we can just know, hey, that's a math fact. That always works out that way. Alrighty, let's move on to number 5 here. So on number 5, 2 over the square root of 12. Well, we're going to multiply the top and the bottom by square root of 12. Top, you get 2 square root of 12. Bottom, you end up getting normal 12, square root of 144, which is normal 12. Now wait, we can simplify though. The 12 and the 2 becomes 1, aka you don't even need it there, square root of 12, over 6. And then wait a second, also, square root of 12, that looks like the square root of 4 times the square root of 3 to me. Square root of 4 is 2. 2 times square root of 3 over 6. Oh, 2 and 6. Those can simplify as well. Square root of 3 over 3 is our answer. Because that 2 simplifies to 1, so we don't need to write it since it's just multiplying. And 3 simplifies to, or 6 simplifies to 3, excuse me. Now, one more thing I want to talk about real quick, guys, while we're here, is just a little bit of an extra example, so to speak. Sometimes you'll see something written where it's like this, okay? Where you'll have let me draw a little quick barrier for myself here, is you'll see something like the square root, you'll see a fraction, so like maybe like, 4 over 5, and you'll see the whole thing under the square root. Well, what's that mean? Well, that's really the same thing as calling it the square root of 4 over the square root of 5. And we would know how to do that. But that's really the same thing. And where we'd go from there is we'd say, okay, well, the top is clearly 2. The square root of 4 is 2 over the square root of 5. And we need to multiply the bottom by both the bottom and top by the square root of 5 over the square root of 5. And have 2 times square root of 5 over normal 5, and then that would be our answer. But once again, the one thing I really want you to notice here is that underneath the radical, right over here, is that when both the top and the bottom of a fraction, the numerator and denominator, are under a fraction together, it's the same thing as them being split. All right, guys, just double checking to make sure I didn't have another slide there. So that is all for today. You are good to go. This should cover you for the IXLs double E4 and double E3, and it finishes up our 9.1 notes there. Excuse me, our 9.1 notes. Have a great day.